to this. All right. So, hi, Moein. How are you?
Hey, how are you? I'm doing fine. How are you?
Good as well. Thank you. Thank you very much. It has been about a month that we could not record any video, and you and I were just talking that it was because you are an intern in Iran, I'm an intern in the US, and unfortunately, when two interns decide to record a video together, the matter of finding an appropriate time could take 1 year. Right? So that's for us. We are lucky that it took only 1 month. So anyway,
Yeah,
yeah,
definitely.
we really wanted to put together a couple of times to talk earlier, but unfortunately, neither of us could do that. A lot of stuff happened throughout the past 1 month. I mean, 1 month in AI world is actually too long. But yeah, at least we are here today to talk about everything that happened. You feel free to go ahead and let's talk about things that you felt like that were amazing during the past 1 month, things that inspired you, and then I can talk a little bit about everything, and then we can
Yeah,
start going through all of them.
yeah, sure. Like last time, we can first talk briefly about what are the main topics or what are the sort of like the main concepts that we are covering. Well, for myself, I'm not covering comprehensively whatever happened in these 1 months, just the most recent ones and maybe one or two things that really stuck with me during this time. And then we can find I don't know, a solution how to start with these presentations. Okay, I start with myself and let me see. Okay, I first want to cover two kind of like articles about how human physicians and AI can perform together to integrate their knowledge to solve cases. And that brings me to the new update on the AIME project by Google.
Perfect.
And then I shift gears a little bit and go to something technical about large language diffusion models, which was very cool, which was released in I think 2 weeks ago. And then after that, I go to something very different about some applications and tools mainly AI powered, but yeah, this is basically a list of cool products that are rated each year by Product Hunt. And I'm going to cover some of the winners and some of the cool tools I found there. So these are the main topics. I'm not, as I mentioned, going to be very comprehensive here. Just, I don't know, to cover some cool topics that I found during these weeks. And
Perfect.
how about you?
Yeah, very nice set of topics. I think that we have some overlap there. I'm also going to talk about Amy. Amy was one of the papers that really inspired me. The second version of that specifically that was just
Yeah.
last week. I have a couple of nice medical stuff to talk about. I wanted to first talk about MedArena, and that was the
Oh, yeah. That
yeah
was amazing.
that's one of the things that we can talk about and introduce it to people. And then some nice products in the world of medicine and AI that is coming out. A couple of nice LLM techniques, chain of draft, for example, that was a very cute technique that I really enjoyed. And then
Yeah.
I also went through some, different studies, mostly research studies that try to understand where we are at the moment with real deployment of AI in medicine and what kind of issues might happen if we nowadays just go ahead and incorporate AI into everything. I guess those papers are also important. A couple of, I have a couple of futuristic topics to also talk about. One of them was the AI co-scientists that Stanford and Google together released that. That was also very inspiring. And also the CL1 device that basically used human or animal neurons to do computations and then
Wow.
come up with AI on top of that. That was so futuristic. I really enjoyed that. And that brings me to one simple question because I have some topics that I'm not going to deeply talk to, to deep dive into, to very extensively talk about, but still they really inspired me throughout the past 1 month. So I'm going to quickly name those for myself, and I would be happy to hear what also inspired you the most before we talk about these items that we have already collected. So, if you remember the last time that we recorded one of these videos, it was almost the beginning of deep research being published by OpenAI. It was only released to pro users, And not too many people were able to play with that. We already had something like that coming out on Gemini. But I believe throughout the past 1 month, a few things happened. First of all, the deep research from OpenAI was also released to Plus users, so I had the leverage to play with that a little bit. And then Perplexity also released that I know that you have been playing with so far. And I know that Grok from X and Elon Musk team also came out and it also has deep research. So I guess now people are basically leveraging this deep research very nicely in different ways. And every day on Twitter, you see many things just produced by deep research. And I think that's
Yeah.
a new paradigm in how we are using these large language models. I really enjoyed that. And then a couple of models came out throughout the past 1 month that each of them were, kind of outstanding from different aspects. So I believe the most important one was the Cloud 3.7, which actually made me go back to Cursor because I had said farewell to Cursor for a couple of months. I was just using the regular VS Code and this, GitHub Copilot or other copilots that we had there. But Cloud 3.7 is so good that I went back to Cursor. I restarted vibe coding and basically just saying what I want to do. And I found one of these applications on Mac that even basically does a speech to text. And it's basically, you just put your cursor on the, put your mouse cursor on the sidebar of the cursor application and just say what you want to generate and just see that a couple of AI models work together. One translates what you say into words, the other generates that for you, the other tests that for you, and maybe after a couple of verbal cues, you have the application that you requested for. Cloud 3.7 was great. Grok, I know that a lot of noises were around Grok and people are still talking about how good this model is. I personally did not work with that, to be honest. I didn't find time to play with that much. So if you have done so, I would be happy to hear your insights. Gemini 2, that was released. I mean, this model is insane. This model is great. Very reliable, very little hallucinations, very long context window. And I was just using a couple of less routinely explored features of that. Like, for example, how good this model is in understanding video files. As far as I understand, this is one of the fewest models out there that you can just basically use the API to feed in a video file, and then the model is able to cache that video file and then answer questions, even give you a screenshots of different scenes of the video that you are describing to it, which is insane. I really like that. And so kudos to Google for this very complete model. And then very recently, this new model from Moein team came out, QWQ, which was a 32 billion parameter model that basically outran DeepSeek R1 in many different benchmarks. So it's a reasoning model in only 32 billion parameters. And 32 billion parameters means that you basically can download that from Olama. And then if you have a laptop or a PC with 32 gigabytes of RAM, you can almost perfectly run that. Or, if you just want to quantize that, then it's going to be definitely runnable. And then you have something almost immediately available to you. So that was also something that really inspired me. The CL1 device that I'm going to talk about in detail, so I'm not going to talk about that much. And then finally, the MedArena quantum chip from Microsoft that really blew everybody out, blew all our minds. So these things happened. I mean, we definitely cannot have time to go and talk about all of this, but I just wanted to mention those really amazing months. I really learned. I even became more excited about AI and things that are happening in this neighborhood of.
Yeah. Definitely. And just to add one thing about these advances that you mentioned is that the cool thing about the Grok model and how X is playing this game here is that it is offering this deep research feature for free, which I think will push the other competitors in this scene to lower their prices or either maybe provide this feature as free as well, which is a very cool thing to just witness that how these complicated features that are really heavy, they need lots of heavy workloads of GPUs and probably cost a lot to these companies, are now made to be available for free for all the users. And this is where competition is helping the whole community to just be able to access these features. I think that's really cool that X is doing that, but personally, I've not played a lot with Grok. I mostly played with Perplexity Deep Research. And I'm definitely thinking about getting the subscription of Cursor because of this Claude 3.7. And I think now it is worth it. Everyone is telling good kind of feedbacks on how Cursor has helped them build new applications. And I really like to try it as well.
Yeah. So if you want to give that a try, let me tell you something. I mean, based on my personal experience, I'm not sure if this is a valid conclusion or not, but this is something that I realized myself. So if you want a full project to be coded entirely in Cursor, you might still run,
Mhm.
I mean, you need to come put together very, very specific rules because the models, the way that Cursor prompts these models, I believe, behind the scene, is forcing them, to do some things that not necessarily are the best for your project. For example, they tend to generate too long outputs, very verbose kind of coding, lots of comments, lots of long doc strings, type hinting. I mean, these are good practice, but not all the codes that I want to come up with needs that amount of doc string, and some functions probably do not need that. So I would say, and a lot of times you realize that maybe because of this very, very long context window usage that Cursor has behind the scene, even the Cursor 3.7 the Cloud 3.7 in Cursor fails to exactly follow what you want it to do. Whereas, for example, if you just do this, if you ask the same stuff from the Cloud 3.7 on the Cloud API, either if you have the Cloud application on your computer, or if you're just using the web-based version of that, that instance of Cloud 3.7 usually does things much better. I mean, at least significantly better, if not much better. And what I ended up doing throughout the past couple of weeks that I was playing with the two of these was that I mostly used the Cloud 3.7 API itself out of Cursor, basically using the web application for putting together the founding cornerstone of the project. The main files, the main scripts, the organization of the files, everything like that. And then I used Cursor mostly for fine tuning. If some scripts needed some adjustments, if I wanted to, for example, change the location of one file and a lot of scripts needed to change accordingly, things like that. So I think that still there is a gap between what the Cloud 3.7 itself is able to tell you and what the Cursor is able to tell you. But the huge advantage of Cursor is that you rarely face into context window issues with Cursor. But whereas, Cloud 3.7 is not the best model if you just are looking at the context window lens. So that this is a downside of Cloud, but I just wanted to let you know that if you're jumping into that, be mindful that Cloud 3.7 at the moment is a little bit more than what you see on Cursor.
Yeah, definitely would take that into account on thanks for the mentioning it. Sure, I think if you agree, you can start with the list and then on the topics that we overlap, we both want to share things. I think that would be simple. We can talk through it and then then we can change the share screens and we continue with the
Great.
recording.
Feel free to start, share your screen, and go ahead. And yeah, we can switch later on.
Okay, so I want to first start with this blog post by Eric Topol. Let me share my screen here. Okay, is it being shared now?
I am seeing that.
Okay. So okay, this is the title is When Doctors with AI Are Outperformed by AI Alone, and that is in contrast to what we hear regularly in the scene of AI, that someone who uses AI will replace you, not AI alone will replace you. And this is exact opposite of that. And this is based on some findings of recent research projects on how people or actually expert humans using AI were underperforming AI alone, which is a really different thing that what media at least tells us what future will be like. And the interesting thing is that it is happening in medicine, that people have some bias against that. There should be a human touch in it, and physicians cannot be replaced in general, and there needs to be some sort of collaboration between human and machine. These are not wrong statements, but as this article uh, reveals, there should be some specific ways that these two components work together. And it starts with saying that okay, AI systems working independently perform better than when combined with physicians' inputs. And there could be many reasons for that. It could be that the physician users were not skilled at using these tools, which I think is very probable, that they didn't know how to prompt it or how to rely on the answers. And the other explanation was that maybe physicians were biased, and they undervalued what the AI said, and they wanted to put more weight on what they taught internally. And whenever the AI was saying something different to theirs, they were sticking with their own opinion and not changing whatever they were thinking. And this wasn't something that was only seen in radiology tasks. It was also seen in clinical decision-making tasks, which is again another maybe not before taught for, and maybe it wasn't expected that this would happen. And here is a table made by him summarizing some of the findings of the recent papers. As you see in chest X-ray interpretation, in mammography interpretation, and also in reasoning and diagnostic accuracy, most of the time, or basically here all of the time, AI alone was superior. The performance was superior to physicians using AI. And mm, they go on providing some thoughts on why this is happening that I talked about briefly, on what could be some explanations of why this is happening, and also some solutions or suggestions of how this combination or this division of labor should be done between human and machine. And they say that rather than assuming that combining both approaches always yields better results, we should carefully consider which tasks are better suited for AI, which for humans, and which truly benefit from collaboration, which I think really makes sense. Machines are better at some things, some tasks, at least at the moment. Maybe someday they are better than everything, but for now, we know that AI is better suited for analyzing very complex data sets with lots of data that could be missed when humans are looking into them. But humans probably are better at human interactions sometimes, and getting some feelings from the patient that the AI doesn't have simply access to. And The path forward isn't about replacing physicians with AI, but rather about finding the optimal partnership model, which I think is the main gist of the whole article here. That we are not looking for whether AI is better or physicians are better. Just we need to find the optimal partnership and how to mix these two sources of intelligence. And here he references the article they published in New York Times. And yeah, here they say what are the probable explanations of why MDs with AI didn't work better than AI alone. And yeah, and physicians aren't completely comfortable with AI and still doubt its utility, even if it could demonstrably improve patient care. And there are three distinct approaches that Eric Topol and Pranav suggest in this article. The first one, let me see. Yeah, in the first model, physicians first start interviewing patients, and they gather information, and then AI systems take it from there and analyze the findings and suggest diagnosis and probably treatments. And they mentioned a study that revealed AI still struggles with guiding natural conversations. And I think the topic of AIME that we are next going to talk about is exactly about this, improving LLMs and AI to being more capable at navigating human conversation, especially in the context of medicine. And here, the study, which was on a model prior to AIME and these recent AI models, they found that AI still struggles with guiding natural conversations and knowing which follow-up questions will yield crucial diagnostic information. By having doctors gather these clinical data first, AI can then apply pattern recognition to analyze that information and suggest potential diagnosis, which I think makes sense to the audience that these models with this long context are good at analyzing these complicated and heterogeneous kind of data sets or data sources about one patient. And this will take a lot more time for a human to do. In the other approach, it is kind of the reverse of the previous process. AI begins with analyzing medical data and suggesting possible diagnosis and treatment plans. And from here, the physician takes on and then analyzes those diagnoses and treatments to see whether they make sense, whether they can be applied. And they can also take into consideration the insurance coverage and healthcare resources, which I think AI can also do so. I'm not sure why they have separated these topics for something that humans are better at. And I don't think humans are better at finding what are the good ways for treating the patient in a way that insurance coverage is the highest. And the final solution or suggestion they provide, the most radical model basically might be complete separation, having AI handle certain routine cases independently, like normal chest x-rays or low-risk mammograms, basically for screening tasks, while doctors focus on more complex disorders or rare conditions with atypical features. And this is another interesting approach, and I think it also makes a lot of sense because these rare cases or novel patterns that AI is not used to based on their datasets, on public datasets, or based on the physicians that have come to a certain institute. Um, Physicians or human experts are better at navigating these cases and probably will yield to a better performance at last. And they mentioned two studies. Basically, both of them are no, one of them is the screening, the mammography screening that we talked about in the previous episode of our podcast, which found out that AIs are able to, that the AI-assisted approach led to the identification of 20% more breast cancers while reducing the overall radiologist workload almost in half. It was a case where AI was separately able to go through the cases and screen those mammograms into healthy or need some revision, some sort of revision. And by doing that, not only they were able to increase the rate of identification of cancers, they reduce the workload. This is basically their third approach, that AI is handling simpler cases, or at least cases that is most confident in, and then it puts the rest of the labor for the human physicians, and by doing so, a lot of time is saved, a lot of cost is saved, and the overall performance is improved. So this was very interesting. First, because that the old saying that a human with AI is definitely going to replace you, not the AI itself, which is probably not the whole picture, at least for now. And the fact that the other thing I was thinking about was that maybe it's not a good idea to um, put a high-end technology like these LLMs and AIs in the hands of people who are not very accustomed to using these. I
Yeah.
mean, maybe we need a new kind of AI-oriented generation of physicians that are kind of like nurtured with these tools, and they know exactly how these models are best used, and maybe these are not something that could be taught to patients. And I was thinking about the example of the things that happen in the industry, like the advance of these online taxis like Uber in the Western countries. And if such an application was in the hands of someone, some old-fashioned kind of taxi driver, probably nothing good will happen. But new people who were not taxi drivers were able to use this new technology in a way that they knew would best help them and help the other users. So I think something maybe similar will happen in here. I'm not sure, but maybe just a new generation of AI-oriented physicians need to be taught or need to be nurtured in some way that could use these tools in a way that AI plus physicians and humans could lead to better performance than AI alone. And or some maybe one of these three approaches that these two scientists mentioned here will work out. I really want to know your views on this and how you think about it. And I stopped my share screen because of the problem of the we have with the a recording of our own webcams.
Yeah, sure. So actually, I wanted to go ahead, and I think it might be accidental, but I had another paper that kind of matches what you were just talking about. So let me share this one with you as well, and then I'm going to talk a little bit about what is my take on this issue as well. So let me share the screen here. All right. Hopefully, are you seeing that?
It is, yes.
Okay, so there is this paper that I went through a few days ago, and it's kind of interesting paper. It was published in Nature Human Behavior, okay? And that's an interesting kind of a study because they think about and they go through different combinations of human AI and try to understand what sort of combinations are useful and what sort of combinations are not that useful. And they kind of, battle against whatever assumptions that we have with respect to collaboration of humans and AI, specifically in medicine. We kind of believe, as we were saying, that, if AI and humans collaborate together, the combination of the two are going to be necessarily better than either of these alone. But they just show that this is not the case. And it's a very interesting paper. I mean, even by looking at the abstract and what they found, so this is basically a systematic review and meta-analysis. So they went through a lot of papers. So this is a secondary study. But here is what they found. So first, we found that on average, human AI combinations perform significantly worse than the best of humans or AI alone, which is kind of interesting. So basically, it means that if there is a certain task in which humans really excel or in which AI really excels, the addition of the other component is not necessarily going to make it better. In fact, it is very likely that it is going to make it worse, which is kind of in line with what you were just talking about. Second, we found performance losses in tasks that involved making decisions and significantly greater gains in tasks that involved creating content. So long story short, they're saying that, if you are thinking about adding AI to tasks that involve components of creativity, then yes, your performance is probably going to increase. But if you're thinking of adding AI to tasks that need decision making, and it's kind of a decision making question mark that in which you are thinking of using some aids for that process, it's not necessarily going to result in helping you. And then finally, when humans outperformed AI alone, we found performance gains in the combination. But when AI outperformed humans alone, we found losses. So the thing is very clear. So if you're thinking of adding the other entity to the task, for example, if you have a task that is being done nicely by humans, you still might see some benefits by adding AI to that. But the reverse scenario is not correct. So if you're seeing that AI is doing a task flawlessly, adding humans to that is going to make it worse. So this is kind of an interesting paper. I'm not going to deep dive into that. It has very nice figures that you can go and take a look at it, and people who are interested might also do so. But basically, these diagrams and the very nice way that they explain everything is going to expand the 3 sentences that we highlighted in the abstracts. This is saying basically the same thing as you said, and this is my take on this conversation as well, which I believe we are at the moment that we are basically proving to ourselves that whatever assumptions that we had about incorporation of AI into our day-to-day practice has been inaccurate and somehow wrong, right? A lot of those assumptions were generated, were created because at some point, maybe we were afraid that if we, very, if we say that AI is going to replace us, then we are going to basically lose our jobs, and then it's going to be a very scary scenario. So we came up with this kind of assumptions that the combinations of AI and humans are always better than humans or always better than AI. We see that, I mean, these kind of very general hypotheses, these do not necessarily hold when we deep dive into different tasks and when we look at tasks that are completely different from one another. So I think that we are in a specific period of time that we are just removing whatever assumptions that we had already, so that we clean the space for new assumptions, for more valid assumptions to grow that will probably come out of new studies like the ones that we just saw, or the minds of scientists that you just quoted from. So I think that we are in a very turbulent period of time with respect to incorporating
Yeah.
AI into our daily practices. Most importantly, medicine, because it's a very sensitive and very critical aspect of practice. I think a lot of things are going to change as we go forward, and we cannot really, stick to those general statements like, yes, AI is going to replace doctors, or doctors who know AI are going to replace doctors who don't know. These things are very, very general, very vague. They do not necessarily hold that much of value at the moment. We should just wait and see what comes. And probably the only thing that we can do at the moment is to just keep ourselves ready to be able to adapt to whatever changes that come in the future as soon as possible. That is the most important thing that we can do now.
Yeah, and I think similar to this situation that we are in has been experienced in probably in the first years of this century with the advent of internet, and everyone was probably guessing in the wrong ways about internet in the first days that no one is going to use internet, who is going to pay for this, and who is going to connect their computer to this internet. And I'm sure you've seen those titles or headlines from the newspapers, the widely known newspapers, saying that no, this internet is going to fail. And at some point, many companies at the dot-com bubble, many companies went down because people got disappointed with the internet advent for some time. So what I want to say is that the course of these new technologies and new ages of technologies that basically are highly difficult to predict. And as you mentioned, the only thing that is kind of like logical to do is to just um, be educated enough to adapt to whatever happens and be fast to jump on the train, whatever trains that comes out of the tunnel, and be able to adapt your skills to whatever that is taking shape. And I think many of these sayings like, no, AI is not taking your job, only some people with AI are going to replace you or something like this, are just heartwarming sentences that we tell ourselves in order to avoid some probable trauma that is going to happen. But I'm not thinking about it in a way that, okay, it is the end of the time and we are going to be useless. I'm sure that there are going to be lots of cooler and more interesting jobs to do than just to type things down about patients and take histories of patients. Probably our intelligence and AI intelligence are going to be used in different places and in the most efficient way. We are just going to find how. And yes, there is going to be lots of job loss and everything. But like always, I think there will be some sorts of new jobs that will be created. Maybe this time there is less jobs created for humans, and most of the things that are intelligence based are going to be occupied by AI. But still, I think that wouldn't be a very bad scenario because people could spend more time on creative adventures and they won't be held without any work to do or something. But I want to know your view about these dystopian and utopian views of the end of the world scenarios and what you think about it, or whether you think about it or not, and you just want to adapt to the current situation and see what happens.
I mean, to be honest with you, I don't know what is coming up. And I think that I mean, many different industries are currently in an uncertain condition, uncertain situation. It's not only about medicine, it's about many, many different industries as well. I mean, I believe the forefront of these changes, whatever changes that we are talking about, is going to be software engineering, right? You know, these software engineers, whoever who has been spent years on that realm, now might feel like even more frustrated than whoever doctor can feel like, because they're seeing exactly what Cursor 3.7 can do, for example. And you know,
Yeah, they will be the first to be replaced if anyone's going to be replaced because
exactly.
software engineers themselves are the most adapt to whatever is happening in the field, and they will invent products to replace themselves much sooner than the other fields, I think.
Yet, you know, if you look at them, you still see a lot of amazing people who are creating these new AIs, who are basically using these new AIs to solving new problems. So I would say that if, you know, of whatever scenario, whatever one-liner scenario that comes to our mind, that this is going to happen, that is going to happen. I mean, the fact that you can describe a scenario in one sentence probably means that that scenario is not true. Because, you know, I would say that the worst thing you can do is to come up with simplified explanations for very complicated and complex phenomena. This is not
Yeah.
the way that the world operates. And if you just go back to history, you see that most of these predictions like that about the future has not been true. So you just need to do a retrospective cohort to see how many of these predictions and modeling that people made actually came true. How many times did we predict that AI is going to extinct humans and it didn't? How many times we predicted that internet is going to replace something else and it didn't? One of them that I clearly remember was, for example, regarding the future of education once the online learning came into existence, and people thought that, you know, online learning is going to replace in-person learning, where we know that this didn't happen. And in fact, something came into existence like blended learning, which was the combination of the two. And then some courses are now better taught through online learning, some are better taught through in-person learning, some are better taught through blended learning. And maybe that's the future. I don't know. You know, some people argue that AI is fundamentally different from all other revolutions like that you're talking about. I personally have stopped contemplating about the future, and, you know, kind of uh, went back and remembered that in one of my MPH classes in Iran, one of my instructors used to say, you used to basically talk about the kind of skills that we are going to need in the future centuries, and always on top of the list was uncertainty tolerance. And, you know, the fact that you and I should learn how to live in a world that is full of uncertainties, as we expect our models to be tolerant and comfortable with uncertainty. I believe you and I should be much more comfortable than them. And this feeling comfortable with uncertainty technically means that, okay, here I am nowadays. This is what I am doing. I need to do it the best way I can. At the same time, I should be very, very ready to switch gears, to shift gears, to switch career, to switch studies, to switch what I am learning as soon as it is necessary, right? And you know, to be honest, I watched a video on YouTube a few days ago. It was from a from a university math class in Iran, I believe in Sharif University, and an instructor was just telling the students about, you know, the fact that we are just solving these very difficult mathematical equations on a blackboard, and you are questioning me that where are we going to use these equations in real practice. You basically are just looking at the story from a wrong angle. This is not about you and us just solving the equations that we are going to use one day somewhere. This is about just getting used to solving difficult problems, because if you just learn that skill, sometimes in your life you are going to apply that skill to another problem that is now going to save your life, save your career, and maybe bring a lot of welfare to many other people. I think that's the most that we can do. You know, we should just stay up to date, stay ready to change, and be a little bit less frustrated about the future, because regardless of whatever happens, we probably will find jobs, we'll find joy, we'll find family, we'll find things to do. And, you know, those who are really interesting about all these new technologies can still have a lot of different opportunities to grow and apply these technologies to many different things. That's my gain on it.
Yeah, and I totally agree. And yeah, so this was the first one that I had on the list.
quite an introduction, a long discussion for the beginning.
Yeah, to be honest, this topic was something that one of my friends who was watching our episodes asked me to once talk about. I mean, there are still spaces that we can dive deep into this question, but he was mainly interested in what are your, I mean, me and you, views on the future of medicine, radiology, and how AI will change that perspective. And I was like, I don't know, but I will try my best to share what is my mindset on the whole thing and what we can at least do in these days to be prepared for whatever happens. But expecting specific predictions for the future, I think at this stage is too cruel. I mean, that is not something that is doable.
Exactly, I agree. I totally agree. All right.
Okay, so I shift gears into something that we both have on our list and is, I think, related to this topic that we talked, at least to the part that in one part, this article by Eric Topol mentioned that AI is still not very good or capable at navigating human conversation in the context of clinical reasoning and taking patient histories. And I want to shift gears to the AIME, which is exactly something that is being developed by Google on navigating human conversation and basically replacing the whole patient physician interaction in the first basically visit. And you can share your screen and then go through it, and then I will maybe add whatever I think is rest to talk about when you were ready.
Sure. So let me share the. So I'm going to share the second paper. Let's see. Uh,
Yeah. I also wanted to start with the second paper first and then reference the first one to see what that was about.
okay. So are you seeing my screen now?
Yes.
Perfect. Okay. So yeah, this is a very nice blog post, very recent one. March 6th, all right, and it came out of Google from diagnostic to treatment, advancing AIME for longitudinal disease management. And then AIME, if you're not familiar with, is a previous publication, not that old, from Google, and this is basically from January 12th, and in which they just introduced an AI system for diagnostic medical reasoning and conversation. So basically, this was an AI-based agentic system that could listen to some patient's history, analyze what they are saying, go and check the evidence, and then come up with some diagnostic tools. And now, on top of that, what this team has come up with is another paper. Let me go back. And now they are saying that not only we diagnose the diseases using our system, but even we go through the evidence and put together some management plans for you. And we even take care of that empathy part and talk with the patients and make sure that the patients are going to receive the best kind of responses that they deserve from a medical provider. So they are basically jumping towards replacing most of the major functionalities of a doctor, at least in a remote visit, throughout a mobile application. And we know that this is part of the day-to-day provider, patient interactions, because not all of the interactions happen in a hospital setting or in an office setting. Some of that happens. Sometimes you just go ahead and talk with your PCP on a mobile application, and sometimes they, ask you questions, provide you with plans. And obviously, if it is something serious, they invite you to go and see them in clinic or maybe go to an emergency room. But from time to time, these interactions happen on a mobile phone. And what this paper is showing at the moment, this blog post is showing, is that maybe we can go ahead and say that now AI is ready to replace part of these interactions. So this is my main take of the blog post. So Moein, feel free to interrupt me, feel free to say your own insights, and then we can scroll and maybe wait on some of the figures, show those, because the figures are great here.
Yeah. No, I mean, you mentioned it, what this new advance is about. And I think the path that Google's taking on this to kind of like complete the whole picture of how AI is going to be integrated into clinical practice and not just uh, focusing on diagnosis too much is very precious. And these multiple visits and then aggregating all the findings and maybe asking for some paraclinic studies to be done and then reason on the results of that is really cool and really close to what actually is happening in the real world of clinic. The only thing that is limiting this study for now is that they are working on or researching with patient actors, as they mentioned, like the OSCE exams that we have in medicine. And this is not exactly like the real environment, but this is a very important environment that no mistakes could be done. So it makes total sense that they are researching with human actors like patients and not real patients at this stage. But I think this paves the way to start clinical trials on really human patients that are not actors to see how these tools compare with physicians. And I think for, I mean, at the first stages, if these clinical trials show good results, just giving patients in rural areas with low access to specialized physicians, I think it is going to be a huge help to the human community. I think it soon could be used in large scale hospitals and specialized cares, points of cares. And I'm really optimistic about this line of research in Google. And I really want to know what they are currently working on that is going to be published soon.
Yeah, I agree. I agree. I mean, this is a very impactful research. As you mentioned, the world of medicine as a whole still is struggling with lots of expert human workforce, shortage. This is something that we are seeing not only in low-income countries, but also even in some industrial countries. Even in the U.S. itself, we have some serious shortages in different specialties like radiology, for example, and not all the states have access to radiologists in an equal way. And this is certainly the case for primary care physicians, for many other specialties as well. And if you go out of the US, go to some poorer parts of the world, definitely this is even a more troublesome issue. So if you have some sort of automated solutions that maybe can take care of at least some of the things that are well known in the medical literature, are well known with respect to their treatment plans, with respect to how to diagnose them, yet still people are dying from them, or the burden of those diseases are very high because we don't have appropriate, a medical workforce to just send to those places and take care of those diseases. Now these systems can basically replace those and hopefully have a very impactful, effect in public health aspects of those diseases. This is what comes to my mind. And to just talk a little bit about the algorithm themselves. So this is a very big picture. This is an eagle eye view of their solution. If you see here, you have the conversation and application that looks like a chatbot. The patient talks with an AI behind the scene, and what happens in this AI system is that whatever presentations that the patient has is going to be analyzed by AI. The content gets processed, and then it is not going to answer your questions based off the knowledge that the model itself has, which is not, a very limited knowledge. We know that these models nowadays get trained on very large corpus of data, and the data that their training data is being more and more cleaned every day. So even if it wants to answer based on its own knowledge, it is not necessarily going to be wrong. But just to make it even more accurate, and just because medicine is a very critical domain, this AI is going to ground itself in some clinical evidence, very well established clinical evidence. The guidelines that we have, a lot of those guidelines are available to providers. We use it in our day-to-day practice. We just, whenever we are in doubt, we just go and check those guidelines and try to see what most recent research has shown to be the best for the patients, and then try to mimic those. And this AI is going to do exactly the same thing. It's going to search through those guidelines, found the best management plan, bring it back, and then it's going to come up with a response based on that guideline. And then finally, the user is going to receive the final recommendation. Another important aspect in this figure is that they are saying that now our model, our AI system is basically capable of handling patient provider interactions across longitudinal visits. This basically means that, you know, the AI's memory is not going to reset every time that the patient comes back, because most of the time the patient provider interactions happens, in a longitudinal access. You come to your provider, you present some of your symptoms, the provider gives you some recommendations, you go and try to follow those recommendations. Maybe 2 or 3 days afterwards, you come back to your provider. Maybe you have done some blood work in between. The results of those blood work is now ready for the provider. Maybe you try the medicine in between, and now you're going to give some feedback to your provider about whether or not the medicine worked. And now the provider can reflect on this new data and also have in mind the previous presentations that you shared with them, and then tell you something new, come up with some new sets of recommendations. That's what this AI system is capable of doing. And this is the base presentation of the model. And as we go forward, they have more interesting figures basically now sharing more details about our system. So again, as you see here, this is the 3 main steps we discussed above, just showing how the management plan is going to put together, and it's based on, again, clinical guidelines, and they talk about what guidelines they're exactly using. I believe they also evaluated their work against some real doctors, and both the AI system and the real doctors have access to equal guidelines. So they removed the confounder of real doctors working with many different guidelines, and they say that we are going to keep the clinical guidelines on which you need to ground yourself equal, and then let's see whose performance is going to be better.
Yeah, and I think these sort of longitudinal studies, if they are done soon in a clinical trial or on a larger scale, considering all the risks and these things, will make a highly valuable data set for training further generations of these AI models, because you can find about the patient's feedback on the effect of the medication, whether the diagnosis was right or wrong, and then these really will give the model a really good source of kind of like feedback on to tune its reasoning skills, and it will make the personalized medicine picture that we all have in mind much more realistic, because this time the model is learning about maybe one medication is not going to work for all the patients with the same diagnosis, and they can come up with different probably adverse reactions or something. And the thing that makes this sort of research really valuable is when it gets done or researched on a huge or large scale population. And designing those clinical trials is, of course, a really difficult task to do, but I think those are just the next steps that we will find a way to take the risks into account and come up with a solution that works best for both the research side and the patient side.
Very true, very true. And I guess, Moein, one point that you and I keep emphasizing in every episode of this video cast is that regardless of how much we advance in terms of architectures and in terms of different tricks for training AI systems, the importance of the data that these systems are trained on is uncomparable to anything else. So basically, the better data you have for training, the better your model's performance is going to be. And, it's not even about the size of the data, it's about the quality of the data. So even if you have a small data set, but if it is as insightful as this longitudinal data that this system is currently interacting with, then probably the models that are trained on that data is going to be much better than models which might be trained on medical textbooks, because now these models are trained on actual patient data, what happens to the patient in practice. I totally agree with that. Let's scroll down. Let's talk about this 2-agent architecture of this system. And this is very important because I believe as we go forward, we are going to see more and more multi-agent architectures in the world of medicine as well. So here they are using 2 agents. And this is very interesting for me because one of these agents is only designed to handle appropriate conversation with the patient. They call it a dialogue agent, and they mentioned that the purpose of this agent is to basically empathize with the patient, which is who is sharing their problems. And this is very interesting because I remember, and back to our previous conversation, one of the assumptions that people had in the beginning that AI started to being incorporated into medical diagnosis and treatment. People said that, yeah, maybe AI replaces our clinical reasoning one day, but it is never going to replace our power of empathy. When you have a human doctor who is talking with you, the kind of feeling and sensation that you receive from a human doctor isn't comparable to any automated robot-like AI that who might do the same thing. And yet you see now that people are actually trying to even get rid of this assumption. Now you have AI agents that their only job is to basically mimic a very empathic conversation with you. And they mentioned that this is behind the scene buying time for this MX agent, which is the main reasoner agent, to go and dig into the literature and come up with a plan. Yet at the same time, you're feeling that what kind of a care I am receiving, right? And if you are a patient, and imagine that you do not know who you are talking to. I mean, you think that maybe this is a real doctor, maybe this is an AI doctor, but this entity that is in front of you is able to take care of your emotions. And that, in my humble mind, is the only thing that matters, because we as humans need to feel calm, right? And a lot of time that I go to bedside, I know better than multiple different medications that we can administer to our patients when they are anxious, say atarax or anything that we want to give them. The simple fact that you just hold their hands and reassure them verbally that you are going to do good, you are going to feel better by tomorrow. This works miraculously, right? I mean, this is much better than anything else. So this first agent, even though it's very simple and it's probably just prompted to respond in an appropriate way to the patient, this is going to be as impactful and as important as the reasoner agent. And the second reasoner agent, as we talked about, this is the one that gets this entire history and presentation from the first agent, goes and looks into all those guidelines and then tries to come up with a plan. And you see here that these guidelines are basically used due to the long context capability of Gemini. And they talk about that if we are using Gemini has kind of enabled us to now feed all these long guidelines into the context window of the model. And this is one of the aspects that makes Gemini really shine. And then they come up with a plan, give the plan back to the first agent that now can, in addition to empathizing with the patient, providing some recommendations to them. So
Yeah. And
yeah,
did you go to the book that is referenced in the first sentence of this section
no,
when on the have human? And that is a really interesting book, and it just kind of like
is that
made me interested in it. Yeah, and this is it. And you can go to the first page of the cover where the um, I'm not sure why the cover is not shown
I
in
can see
here.
here. Let's see.
Yeah.
Yeah, it seems that the book original pages, maybe starting from here, front matter.
Yeah.
This
Yeah, let's go to the
I can see. Improving diagnosis in healthcare.
yeah.
Let me go on.
Improving diagnosis in healthcare. And this section that is referenced, I read that the dual process theory and diagnosis. The diagram was really cool, and how the doctors handled the diagnosis scenario was kind of like described in very good details. And also the next section right after it is probabilistic or Bayesian reasoning in this book, which is about improving diagnosis in healthcare, which really intrigued me to go peek into and see how they are actually describing or using Bayesian theory in the diagnostic cases for physicians. And yeah, it was just cool to see how these theories are being applied basically in something in medicine that really needs to, I mean, the physician really needs to know about the probabilities of the or the prevalence of diseases to see if it makes sense that this patient with these symptoms really has this diagnosis. So yeah, just something cool that was referenced in this blog post.
Yeah, nice. So is this the book that is this the same book? I
Yes, I think so. Yeah.
This was a diagram that you were talking about, or I mean, do you mean the book cover?
I think it was this one. I'm not sure if it's exactly the right edition or something.
Or
Um, let's see from the authors, Erin Bullock, Brian Miller. Can you see them in the Amazon page?
let me go back there again. Uh, yeah.
I think that's the same thing, yeah.
So maybe we can see that diagram here. Let's see.
I think it was on page um, 44, I guess.
Or the
Let me, you can just click on the link again and it will directly go to that section
yeah, I think
from the blog. Yeah.
the problem is that I accidentally closed the blog post the page, so I need to open.
No problem. Let me see what page it was. It's on page 59
And I'm trying to
of
open
the book.
the blog post itself. I believe I had the link somewhere here.
Mhm.
Probably the page. Okay. So you said to come here and click on this link again?
Yes. Yeah. And it should go to the right section. Yeah, the dual process theory and diagnosis. And it basically references the Daniel Kahneman System 1 and System 2 thinking and how experts, physicians, most of the time, or after they get expert actually at what they do, refer to System 1 of thinking when a patient is presented to them. They really quickly can match the pattern of the symptoms and signs of that patient to some disease model that they have in their mind. And it says that medical students and novice physicians most of the time use system two of thinking because they don't have really rigorous or
Yeah,
sophisticated mental models of diseases, and they need to just go through every sign and symptom, and they don't have a good pattern matching skill at the time. And it was a really concise but really informative section. And the next section, which is on Bayesian reasoning, was also really interesting to follow. That's I'm probably going to read in the next few days.
this book is actually something that I didn't have on my radar. Thank you for, I mean, I kind of overlooked that in this blog post as well, but I should definitely go and take a look at these chapters at least. Looks a very nice book, and
Yeah.
it's kind of fascinating that they are going through such literature to put together.
Yeah, exactly. And it shows that they have a really multidisciplinary kind of theme, and they're taking this really seriously, that they are diving deep into the textbooks in the medical domain, and also taking into account the concepts in there, and then applying these LLMs to match at least what is established in the kind of like the diagnosis field of medicine.
Yeah,
And yeah, this is one of the reasons I really like these teams' works, and I'm really optimistic about their results of their next research projects.
I agree. I agree. Let's see if we have anything else to share from here. And I believe we talked about most of that. This basically now gets into the
Yeah.
nitty-gritty details of how these outputs are made. And I believe it's very interesting how structured the entire output and the entire management plan is coming out of the Gemini models here. So very, very nice work. And let's talk maybe a little bit about the evaluation of their work as well. So as we can see here, they basically had a longitudinal kind of setup. So here we are looking at three different visits. And as Moin mentioned, this is with respect to patient actors. So these are not real patients. Obviously, these are just patient actors, but they are educated patient actors. So they know how to, I mean, they are well trained about what presentations to have and how to communicate those presentations with the physicians. And obviously these PCPs who participated in this study probably didn't know if they are, and I assume that they didn't know that they are talking with a patient actor. They probably were just treating a real patient. And then what happens is that this simulated patient tries to converse with whatever agent that is behind the mobile screen, which could be a real PCP, which could be AIME. And then whenever the AIME was called, the entire process that we just talked about was initiated. So basically, they put together some conversations, And then the data between the visits were also fed to the model. So for example, if some test results are back in between visit 1 and 2, and then the model is going to take into account those results as well. And then it goes through NICE guidance and BMJ best practice. So these are two sets of medical guidelines. And the model tries to ground itself within those guidelines, and then based off those coming up with some evaluation and maybe management plans or whatever, and then it goes back to the patient actor acts based on that, and then the third visit happens, and now the process goes on and on. And then we have this very nice, very interesting evaluation results page, and a very simple one at the same time. You see that this is the red dots, the red curve basically is showing AIME performance, and the blue is the control PCP group. So you see that, for example, the appropriateness of the management plans, the preciseness of that, of avoiding inappropriate recommendations. When you look at most of these, almost in all of them, AIME actually did better, which is kind of crazy, to be honest with you. And
Yeah.
I understand how physicians then become kind of scared and frustrated when they look at these kind of outputs.
Yeah, exactly. And one of the other trends that you can see is that by the performance is getting better in some of these plots after the visits gets accumulated. So it's, I think, signaling that probably most of the time maybe the right diagnosis is not just made in the first visit, and the treatment and the course of the whole diagnosis and treatment is best done if multiple visits are done. And of course, more data will be gathered and probably test results will be back. So yeah, I think that is another pattern that you can see at least in some of the plots here.
Yeah.
But yeah, and most of the times the AI is again outperforming physicians.
Yeah, and I'm mostly interested in this diagram, Moein, specifically. This is the third diagram on the investigation section. So you see that the way
Mhm.
that I understand it is that when the patient first comes in, both the human doctors and AI doctor kind of order the same sort of labs or tests to be done for the patient. But from the second visit onwards, it seems that the AI acts much better in keeping the in keeping the list of investigations proposed to the patient short, whereas probably humans are actually ordering more and more diagnostic tests. Some of those might not even be necessary. And this is something that we do see in practice as well. I mean, sometimes we just order too many labs, too many diagnostic tests for the patient. Part of that might be because the provider is not that certain about the diagnosis. Maybe they don't have the intuition. And as you were just talking about, type 1, type 2 thinking, maybe they are not that well trained in pattern matching and intuitive thinking. But I mean, looking at it from a patient's perspective, this is just a huge amount of money saved between these two lines, right?
Yeah,
Because the patient
definitely.
spend a lot of money for tests that are not that necessary. Whereas if AI is proposing those tests, maybe the tests are maybe the number of tests that they need to go through is actually much fewer, and then the amount of money that they need to spend for their own health is actually much less. And this means
Yeah.
a lot. Means a lot. Very
And also the gap is even bigger on for the same title in the treatment part, the
yeah,
treatment sufficiently precise, which is again another interesting finding. And all the three comparisons are significant in the statistical test that they have done. And yeah, again, lots of costs will be saved here by not probably too much prescribing things, and lots of adverse reactions are
yeah,
avoided.
yeah. Very, very interesting figure, very interesting work, and I guess we can talk for the entire video about this article and the
Yeah.
previous one, which let's just bring it up for the sake of being loyal to their work. So this is the first paper that came out, AIME, and this is also a nice one. I mean, we are not. I think we probably do not need to deep dive into this unless if you have something to say or share about this one. But I guess this is exactly the engine that they used in their second work as well. So two very interesting blog posts for people who want to learn a little bit about the work that Google did and probably is going to lead the future of AI incorporation into medicine.
Yeah, just something about the last figure of this very blog post. Yeah, this one. And I think you remember when this paper was published. At the time, they weren't called this AIME. They just mentioned it is a specialized kind of Gemini model that we are working on. But now they say that this was basically the precursor of AIME. And again, the pattern that was mentioned in the first blog post by Eric Topol was first probably seen here when AIME alone was doing much better than clinicians assisted by AIME or by search or unassisted, which was the first findings showing that maybe the picture that we have that physicians with AI are always superior to either of them alone. And here you see that again, the AI outperformed the clinicians even using AIME itself. So yeah, it was cool that I found finally that the model used there was basically AIME and or the precursor to AIME.
Yeah, exactly. This is a very nice figure, as you said, and again, so I'm very happy that I will have a chance to present. I'm definitely going to present this paper in front of some of our medical colleagues in the hospital that I'm currently practicing in next Wednesday, and I really want to see how they react to that. Maybe by the time that we come back together to record the next episode, I can tell you some of their feedback about this. Uh,
Yeah, definitely.
I kind of can imagine what the reaction would be, but I don't want to go ahead of myself and try to get something that is wrong. But yeah, I mean, I can imagine that
I
the committee is not.
Yeah, I remember at the time that one of the complaints that physicians or the community as a whole was making about this research was that, okay, maybe those NEJM cases, those complicated NEJM cases that these were evaluated on, maybe those were in the training set of the AI model, so it made sense that they are working better. But based on the figure I shared from the Eric Topol blog post, this result is replicated in many other research projects as well.
Yeah,
Of course, there are controversial results in other projects showing that, yeah, people or physicians with AI are outperforming AI alone. But I think this is some finding that is being replicated by other projects that couldn't be ignored.
no,
Uh, or of course, there isn't going to be a simple a solution or explanation of when this is happening or on what task this is happening. But this is some finding that at least in some tasks in medicine, AI itself should be let alone doing whatever it wants, probably, or maybe not that extreme, but AI alone is at least outperforming others. And maybe in some other tasks, maybe humans alone are better. And this was basically what the first article was suggesting that we should just separate the tasks and maybe let them do their work and then aggregate them on some higher level after they worked separately on their own tasks in order not to interrupt or basically bias one's conclusions with the other mindset, something like that. Yeah.
I totally agree. I totally agree. And let's wait. Let's wait to see what happens in maybe 1 year from now if such tools are actually used in practice. And I think that there are some people out there that unless they really see some patients being treated by these AI systems, they are not going to believe their efficiency and their efficacy. But I believe that sooner or later we will see some of these tools being used in medical practice as some people never believed that we are going to have autonomous cars, and now we are seeing those on our streets. So these things will also come into existence.
Yeah.
All right,
Yeah.
so Moin, let's go forward. I have a couple of things to share, but do you want to shift gears and maybe you share something, or do you want to
Mm.
go ahead and share something?
Um, Uh, to be honest, because of the problem of the webcam sharing, I prefer that you share the screens on the cases
I
that we now shared
Okay,
material.
right.
And I was thinking maybe it's a good time to just mention the MedArena that
That's what
we both have on our list.
exactly. That's what
And yeah.
let's go through that. I have that one to share, and another thing that I kind of found interesting as well.
Yeah, feel free to yeah, whatever you want to cover next. But
I mean,
yeah, this was
this is
just
something
one suggestion.
fun, to be honest, and you're not
Mhm.
taking a look at behind the scenes. This is how I put together these articles usually. Let's take a look at this one. I want to find that out. Hard Truths About AI in Healthcare. I'm not sure if you have seen this website. This is a nice blog post that I came
Interesting.
about. Very nicely done by Jan Baker. I mean, this looks like
Oh, yeah, I think I know him. He usually posts kind of like summarizes important AI papers in the field of healthcare. I really like his posts on LinkedIn.
yeah, exactly. Nice social media presence, but I didn't know that he has also put together this blog post. And this is kind of interesting. I mean, one day in the hospital, when I had time, I started to just carelessly scrolling this and see what I found. But even though the sentences are very short, you will probably end up thinking about some of them for an hour at least. So, and this is a living document, as he has mentioned himself. So this is just being updated. The last time I checked this, it was 60 facts. Now it has become 80. So he's keeping adding to that. And as people see that, he is going to add things. So it just starts with very simple statements. AI in healthcare isn't coming. It's already here. The real question, will we use it wisely or let it fail? The era of AI pilots is over. It's not adopt or fall behind. So some of those, I mean, not necessarily you are going to agree with all of the things that he mentions here, but the fact that these sentences are here and some people are thinking about these sentences is valuable. So basically, you can also ask yourself whether or not you are going to have an argument for or against any of these. For example, today AI backs up radiologists' expertise, reinforcing their knowledge and decision making, which we already know is true. Many of our, at least in the US, many of the radiology many of the radiologic centers, many of the imaging centers, or even academic centers have AI already deployed into their PAC systems, and AI is auto-detecting some of the abnormalities for them at least. And this is, for example, I found this sentence very interesting the first time I read it. The real AI revolution is happening in the back office. While everyone focuses on clinical applications, AI is quietly transforming healthcare operations. This is very important. I mean, we think that, and we tend to think that, I think even more than us, people who are out of the world of medicine tend to think that medicine is all about diagnosing diseases, coming up with a management plan, and then treating patients. It's not like that. Behind the scene, this entire huge industry of medicine is being operated by a lot of different operations that is something like, how to keep the hospitals clean, how to keep record of whatever patients that come to the hospitals, how to manage the workflow of the patients, how to do triaging in the rooms. Things like that are less talked about. They are very, very important. I believe AI is already being applied to those as well, even though we just have a detection bias and tend not to discuss them. So anyways, this is...
Yeah, when you were mentioning this, one other example that came to my mind was to how to optimize the distribution of human labor in medicine into the whole country. I mean, where to put which kind of specialties, how the population is growing in certain areas to care about what the specialties they're going to need. And I think these are really problems that AI is very fit to solve, and it's not that risky to put it on the AI side. And probably not many people are thinking about these kind of applications. As you mentioned, everyone, when AI is mentioned in medicine, just thinks about diagnosis and radiology and something like that.
Exactly, I agree with you. And again, so this is a nice read for people who are interested, and this is the statement that you just talked about. AI doesn't need more data, it needs better data, and I believe you probably can find a lot of the things we
Interesting.
have so far talked about here. Yeah. So this is one thing, and now let's talk about that MedArena that I introduced earlier, and this is a very cool website that came out. So some of the people who are watching us might already be familiar with LLMs, if I'm not wrong, and
Yeah.
now it should be
Yeah.
because the name was changed to Chatbot Arena, if I'm not wrong, something like that. LM Arena, yeah, Chatbot Arena.
Yeah. Formerly LMSIS. Yeah.
So this is a website that comes out of the engineering part of the world, and these people who are in the software engineering, developing LLMs and LMMs, they just put together kind of a head-to-head battle between different models in an anonymous format, so that you and I can go there and just try to, for example, ask whatever question that we have in our mind from two random models that we don't know what they exactly are, and then see the responses, and then for example, tell me a joke, and let's see what happens. and then two models start to generate a response for us. And I believe this is just based on grad.io as far as I understand.
Yeah, it really looks familiar.
grad.io. So basically, you just see it here. Here's a classic one. Why don't skeletons fight each other? Because they don't have the guts. And then here, why don't scientists trust atoms? Because they make up everything. Uh, I believe A was a little bit better, to be honest with you.
Yeah.
So now that I scored this, you just simply understand that, interestingly, Model B was Cloud 3.5 Sonnet, and Model A is Roman
It was
Empire.
Roman Empire.
That I'm not even sure what Roman Empire is, but apparently it does a very good job in telling you jokes, right? So
I think this is one of those kind of names that one model is being published just to see
right.
what the score is going to be, and then we find out, okay, this is the next project by OpenAI. They just didn't want to share the name.
No, you're right. You're right. So probably this is such just a model that has not yet been released. But whatever it is, I would love to see. Now keep this name in mind
Yeah.
next time we understand what Roman Empire.
It looks like some name that Elon Musk will give his models. So I really doubt whether it's the next version of Quark. Yeah.
For maybe, but anyways, so this was the original chatbot arena or LM arena that came out, and people used to work with it. This is one of the most reliable kind of benchmarks whenever we are ranking LLMs, because it is very fair. You and I can go there, and as simple as you just saw, we can rank one of these models better than the other. And now we have the same thing in medical words. So people, and I would like to find out who actually created this so that we can give them some credit. Yeah, from Joe Lab, from Stanford. I'm
Yeah.
to open.
He's a really good researcher. I mean, I really like his work. James Zhao, I think.
Yeah.
Yeah.
So Dr. Zhao, very incredible and impactful piece of work that he and his lab did from Stanford, and they put together something very similar to LM Arena, only for the LLMs used in clinical area, and they call that MedArena. And it is MedArena.ai. You just can come here. At the moment, if you want to play with this, you just need to have an NPI. An NPI is basically a national provider identification number that physicians in the US have. I'm not sure if they have or they will have anyway for physicians from other parts of the world to also take part in. As of now,
I think, yeah, they were opening up, and I mean, there was a cool comments when they shared this MedArena on their own LinkedIn page. Someone in the comments said, "You know that MDs exist in the other parts of the world other than the US," and they said, "Yeah, we know that, and we are doing our best to make it possible for MDs from other parts of the world to take part in it." And I think for now they are asking for a kind of like a license number or something equivalent to NPI, and they go probably manually through them to verify them, but they are thinking about adding that.
yeah, exactly. I hope so. I hope so, because this is a very interesting piece of work, and I believe these models will benefit from more people evaluating them in the long run, and specifically if the people are from medical industries in different places of the world. This ranking will become better and better in terms of addressing needs from different geographical regions. So this is something very cool. And again, the way that it works is very similar. So say, for example, if I ask a question here, what is the best antipsychotic medication for an admitted patient with delirium and long QTC? And so we know that these antipsychotic medications are not the best choices for people who are delirious in the hospital and have long QTC in the hospital under EKGs, because it can make things even worse. So now let's see, two random models are going to come up with an answer. I am not quite sure. Based on my knowledge, once I looked this up for a real patient, and the best answer was quetiapine, if I'm not wrong, but we can take a quick look at it. So this one is saying that I am not a medical professional, and this information is for general educational purposes. Always consult. And they're going to talk about why.
Could you zoom in a little bit? I think.
Yeah. For sure. Thanks for the reminder. Let's zoom in. So I'm first reading Model B because Model A apparently answered the answer that I like more. I just want to see what Model B is saying. So it starts by saying that don't rely on my recommendation, which is a good a starting thing. And then it says that the usual go-to antipsychotics, while every antipsychotic has some degree of QT prolongation risk, which is a true statement. One of the agents considered to have among the lowest impact on the QT interval is aripiprazole. That, to be honest, I've never used inpatient for any patient, but maybe lower propensity for QT prolongation than many atypical. And then some explanations, important considerations in practice. All right. The very first thing that I really wanted to see here was citing some references that I'm not seeing. Now let's go to this one. This one is saying that it's quetiapine, and I honestly am more in agreement with this with my very limited medical knowledge at this point, but I prefer quetiapine to other ones. And then here are the key points from the studies. And this one is actually citing some references for me. Let's just open one of them, make sure that this is not a hallucination. There we go. Comparisons of antipsychotics for the treatments of patients with delirium and QTC interval prolongation, a clinical decision analysis. This is exactly the kind of paper that I needed for answering this question. So for me, the winner of this head-to-head battle is very clear. It's definitely model A. It is using references. It is giving me the answer that I have already heard about, and I know that it's going to be the good choice. So this medication usually goes with the name Zyprexa in the hospitals, and we usually order that for the patients who become delirious and have long QTC. And then we can go ahead and continue the conversation, or we can just, as we did with the MedArena, just say that I prefer model A. And when we do so, we understand that, look at this, Moein. Model B is OpenAI O1, which is basically their best reasoner model that actually gave me an answer that looks like to be wrong and is not citing any references. Model A is Perplexity based on Llama 3.1, even not the Llama 3.2, sonar large. So, I mean, Perplexity is definitely winning this small battle that we had here, and it shows to me that I'm not jump to conclusions based on one comparison, but I think that for such questions, Perplexity is going to be better than just asking ChatGPT what to do and what not to do.
Yeah, I think those kinds of models that can search internet and look for the guidelines or the latest research in the field are going to be much more suited for questions in the medical domain, because everything is changing very fast, and these guidelines may not be available in the weights of the model very easily, probably buried with lots of other information that will make it difficult for the model to differentiate which source of information was in the guidelines and which weren't, but most of them are available online. So if the model has access to the internet and can search, I think that would be much more reliable.
I agree. I totally agree with you. And then let's just take a look at their leaderboard and see what models are standing on top. So, interesting. I didn't know this. Interestingly, the best model so far is Gemini 2 Flash Thinking, which, if I
Yeah.
am not wrong, is the same model behind the AIME AI system we just talked about. I'm not sure if they are using the thinking version of Gemini 2, but I believe they were using Gemini 2. I'm going to correct me if I'm
Um,
wrong.
yeah, again, I'm not sure for the thinking part, but yeah, this is the latest version of the Gemini family model, and it was basically the thing that is powering AIME.
Yeah, and very, very nice that we see that on top. And then we have GPT-4o, and then O3 Mini is on rank 5. And again, very interesting, Gemini 2 Flash is better than the Reasoner model from OpenAI on doing things. So
Yeah.
I am now becoming more and more fan of Gemini, to be honest with you, even on simple use cases when you are just using API. My recent codings were mostly based on Gemini, and it's doing a great job. The API is good. Even you can just use it with OpenAI like APIs, and now you see that on these rankings, it's also two of the OpenAI Gemini models are in 1 to 4, and they are outrunning the O3 model from OpenAI. So
And the interesting thing is that I'm not sure if other LLMs are or were included in the whole competition here, but you don't see any specifically medical LLM here. All of them are general LLMs that are answering medical questions on the side, but some of the fine-tuned versions of these LLMs that are published for the medical domain. They aren't listed here. It would be cool if they are included. Maybe they are included and they're losing. I'm not sure.
I don't think so because if you scroll down, they have this head-to-head
Mhm.
comparison of every single model in their arena against each other, and I believe that the only models that they have included are these 9 models that we are seeing here. So maybe in the future they add more models. To be honest with you, I think that part of the story is also the copyright issues that such models usually have because very few of those models, as far as I understand, are available as as kind of open source on GitHub or maybe somewhere to use. And if they are, maybe the copyright does not permit that. And even if the copyright works, maybe those models are not yet prepared for whatever question answering, general question answering in all fields of medicine. That might be the reason, but I would be happy to see some of those models here as well, as you said. So again,
Mhm.
very cool website, and I believe we need to advocate people
And
using this arena as much as possible.
another interesting thing that I found in this leaderboard that makes my previous claim kind of wrong is that the first model is not doesn't support RAG. So it's
Really?
just answering questions based on whatever knowledge it has. And
Okay.
this is crazy that it knows this much about medicine.
Uh, so that makes me think that maybe it is because the very large context window that Gemini 2 has. Let's see if we can find any comparison of the uh, LLM context window comparison. I think that we should see some sort of.
Yeah, but I think most of the questions people will ask in this scenario will not occupy lots of input context.
No, I believe that because so maybe they are using that with RAG. It's not. So Gemini 2, you said that Gemini 2 Flash cannot do RAG?
In this, if you go back to the MedArena, they use the icon of those books on the book pile for the models that support RAG, and this doesn't have that. The Perplexity model, of course, that had supports RAG because it searches internet and then augments the whole thing with the results. And Gemini 2 Flash itself supports RAG, but the thinking version, as we have seen this with the DeepSeek R1, the reasoning ones don't support RAG in their raw form.
I agree. Now I understand what you say. Though I think that what they probably meant here is that if you want to upload an image or maybe upload some references and test the models
Hmm.
being grounded in those, then for that sake, you should be careful of which models you are playing with. Uh,
I'm not, yeah, that could be another explanation of what they mean by these, but yeah, I'm not sure
it's
which
still,
is the
yeah,
correct.
very interesting, very interesting. Regardless of how Gemini did that, the fact that among a lot of battles, 136 battles, they are still top there makes me very amazed at their work. All right, so this is MedArena. What else do you want to talk about? What else?
I'm okay with whatever direction you take it on. Let me see what I have
You
still.
picture. I'm
Mm,
going to stop.
Yeah, there is the large language diffusion models, which will be a shift in the topics that we are talking about. And there will be the tools from the product hunt that I wanted to cover, which is again another whole different thing. Maybe just a quick mention of a paper and an article on the medical part, and then the rest of my list are just technical things, not too much relevant on the medicine.
Okay, so feel free to go ahead.
Okay, so I start with this one. I think you can see this again from the Substack of Eric Topol. And I really quickly covered this because my knowledge of this space is really limited, but I think it's another important area that you're going to see more from in the next few months, probably. And the first diagnostic Immunome, and this is related to scientists going to sequencing. Let me cover here. Yeah. they go and sequenced the heavy chain of the B cells on which is one of the receptors, and also the beta chain of the T cells. And these receptors are built in these cells based on what antigens the patient is exposed to or what disease they have. And the theory was here that, okay, lots of information is encoded in the sequence of these receptors of the immune cells of patients. Um, why not we gather a big data set of these sequences and train a generative model on these sequences, and then try to use these generative models to classify basically based on the new unseen blood samples of new patients to see what diseases they have based on, I mean, those generative models had access to what diseases those patients in the training data set had, and what sequences these receptors had. So they find a kind of a pattern among the sequences and the diseases. So this knowledge could be used on unseen cases to go from the receptor sequence to what the disease they have. So the promise here is to just take a blood sample from a patient, and based on the sequences in the immune cells, or in combination with other features like some other proteins in the blood sample and lots of other clinical features, come up with a more accurate diagnosis. And this is in the space of the proteomics and immunomics, this omics kind of like world that you gather whatever data you can from the patients, and then you come up with the more personalized and more accurate diagnosis for that patient. So it was new to me that this sort of information from the immune cells is going to be used again with AI to help with the diagnosis. And based on the paper, let me share the blog post by Nature as well on this topic. Um, this was the first work that was done on the successful use of Immunome to diagnose diseases. And it was done for autoimmune diseases like lupus, which are very difficult to diagnose. And the criteria for the diagnosis is changing every few years, as you've seen in the textbooks.
Yeah.
And yeah, Nature had an article, AI tool diagnosis diabetes, HIV, and COVID from a blood sample. And the one-shot approach that uses machine learning to screen immune cells could help to detect conditions with overlapping symptoms. And I think with what AlphaFold is doing on proteins, and with what these teams are doing with these receptors of immune cells, we are going to have lots of lots and lots more information about each patient in the future, and these will really make help make more accurate diagnosis for the patients based on just probably simple blood samples. And yeah, this was something that I just wanted to mention in this episode, but I've not dived deep into how the model is trained, and I think it wasn't that detailed in the paper as well. So this was one thing, and then the rest of the things on my list are non-medical things. So if you have anything else you want to cover first, feel free to share.
And first of all, this was very interesting. I really like the idea of taking a look at into immunological cells and then looking at the receptor proteins, which is something that, but will not immediately come to mind. But if again, if you have an interdisciplinary knowledge, you might
Yeah,
find
yeah.
very, very interesting niche areas of science to work on. And back to our very, very first conversation on this episode, that you know there are going to be lots of new opportunities for people who are still interested to remain in science. I mean, who thought that one day we can just come up and basically look at immunological cells like these and then apply AI on that to come up with some diagnosis, and a lot of cool other things could also happen in future. Thank you for sharing.
Yeah.
I have two things that might kind of shift us, help us shift gear from medical words to more engineering word. Two
Hmm.
different, both very futuristic kind of studies that I would like to share with you. Let me open those.
Sure.
and share my screen with you. Both of those actually raised a lot of attention. I am going to first go to this one, so let me share. Sure, and then we are here. Hopefully you're seeing my screen now. All right, so this is the first paper towards an AI co-scientist. Came out on February 26th, and this is from Google and Stanford, and I bring from Imperial College, so multi-institute kind of work and with lots of co-authors, as you can see. And they did a phenomenal job. I mean, this is not the first time that we are covering an AI system to help with research. I believe that we once talked about a kind of simulate
Virtual lab idea kind of thing.
exactly
Yeah.
virtual lab with some agents for trying to mimic the entire processes that happen in a lab. This paper is basically just focusing on the first part of any research, which is to come up with, I mean, worthy proposals, or maybe worthful kind of hypothesis to work on. So they are not going to do an entire research using AI. They are basically putting together a multi-agentic AI framework to just look at the literature, maybe receive some feedback from the human user to understand what field they are interested to work on, or what is the problem that they are mostly interested in. And then they come up with some proposals and hypotheses for them to work on. And this is a very interesting paper, not only for the sake of the multi-agentic AI framework they propose that we're going to talk about, but because they basically tested their protocol, tested this system on three different problems, three different real problems. And then they kind of try to validate the proposals that the model came up with, or the AI system came up with. And it created a lot of hype around how AI is going to revolutionize research, because some of the hypotheses were so cool and a state of the art that even the actual experts who are working in the field were kind of amazed at how this AI system could basically come up with those proposals in as short as maybe a couple of hours, or I believe the longest one was 2 days only. So this is a very cool work. So let's take a look at the way that they are doing this. And again, if you look at the entire framework, it's not that complicated. Something that you can easily do. I mean, easily might be too much of a oversimplification of or underestimation of their work, but basically not that challenging to do with now all these agentic frameworks that we have. So here's the human scientist. The human scientist interacts with the system by specifying a research goal in the natural language. And then they can also suggest their own ideas and proposals, provide feedback and reviews, and interact via a chat interface to guide the co-scientist system. So exactly, you are just dealing with an intern, imagine, but this is just a PhD level intern, somehow someone who knows a lot. So the scientific inputs could be something like that. Scientific describes the research goal along with preferences, experiment constraints, and other attributes. And then from that point onwards, something happens. So first of all, the AI, the first agent is going to receive this kind of research goal and some configuration, and go through the literature and figure out what is happening in the world that the scientist is interested in. So it basically is a literature review agent that digs all the possible literature that they can access to using regular search. Then whatever they find comes to a reflection agent, and the reflection agent is going to just reflect on whatever things that we found, trying to write full review, trying to somehow simulate a review. And they even have something that they call a tournament review, which is very interesting. And tournament review is basically a kind of competition between different hypotheses or proposals. So imagine that this AI agent is coming up with 5 different proposals, and now they are putting together a contest in which these different proposals are going to be challenged against each other, are going to be tested against each other. And who is going to test that? Again, another agent that is now going to take care of just comparing these hypotheses towards each other and ranking them from the best to the worst. And then afterwards, this is a loop itself, so it can go on and on unless we are kind of satisfied with the proposals that we have. And then another agent named evolution agent is going to make them a little bit simplified, make sure that parts of those that could be inspired from already developed ideas or already mature ideas are actually changed as necessary, and then the research is extended. So basically this makes the proposal a little bit more mature. And then finally, the proximity agent, to be honest with you, I'm not quite sure what this one is doing here, but I believe the meta review agent is going to finally put together in the format of a proposal. And these proposals are going to be shown to the user. The user can obviously provide feedback, and this loop goes on. And whenever the user is satisfied, basically you have that they are going to have the proposals. And there is obviously these are agents, so they have access to memory. They have access to some tools to use. The first obvious tool is a search tool. They can search the internet and they can come up with additional tools as needed. And this is how the system works. And now the three systems that they've worked on, which is basically this second, I'm not sure if you've seen this part. This second part
Yes.
figure is talking about those three different experiments. So this is three different case studies, better to say. The first one is on drug repurposing for acute myeloid leukemia, or AML. So they said that let's use this system to see if we can put together some new medications to treat AML. And this was the prompt. As short as you can see on the screen, suggests an existing drug that could be repurposed for acute myeloid leukemia treatment and provide experimentally testable concentrations for an IC50 assay, which is an immunologic assay apparently. The drug should inhibit the proliferation of AML cell lines, particularly this specific cell line that I'm not familiar with. It's one of the cell lines within AML. And with preclinical evidence, and so this is the AI co-scientist generates predictions for AML drug repurposing. Scientists review and select candidates for in vitro experiments. This is the interesting part of that. So they took some of those medications and they went to the lab, to the wet lab, to create those and see how they do. So some of the medications that were repurposed, or basically AI proposed that this could have some benefits here, were binimetinib or pacritinib, some of those immunologic medications. And then they went to the lab, and in vitro experiments show that the proposed co-scientist drug repurposing candidates inhibit tumor activity in AML cell lines, which is kind of interesting. So let me just quickly scroll down and see if I can find a better kind of figure for this one to share it with you, because this is a very long paper, by the way. This is about 80 pages. And they evaluate everything very, very nicely. To be honest with you, I'm a little bit, I'm gonna be a little bit naughty here and say that, nowadays I'm a little bit pessimistic about how much of these very, very long articles are written by human. But this is a very solid work, so I'm pretty much sure that even if it is part of that is AI generated, everybody has gone through it to review that. So, yeah, but let's come here. This is the one of the results figures for that first task. No, sorry, it should be here.
Oh, yeah. That was for, I think this is it.
This one or the previous one, I guess maybe this one. Yeah, so yeah, this is the one. So they are basically showing how these three medications that the AI agent proposed are reducing the concentration of those cells within the in vivo environment, so in vitro environment. So basically you see that, as we increase the concentration, I believe, so this is a dose response curve. So those three medications inhibit MOLM13 cell viability. X-axis is the drug concentration. So this is the drug concentration. And then and y-axis is normalized cell viability. So definitely if a medication is more effective, then the viability of the cells should be lower as the concentration of the medication increases. And I see that some of these medications, specifically this one, binimetinib is going to be super effective against that. This was one task. And let's also look at another task. And this is also interesting. So again, they are looking at another kind of big challenges in medicine, GI, basically the concept of liver fibrosis. And they are saying let's look for novel treatment targets for liver fibrosis. So propose a novel hypothesis about the specific epigenetic alterations contributing to myofibroblast formation in liver fibrosis. Okay, so they're looking for what is causing that fibrosis. The AI co-scientist identifies three novel epigenetic targets. Now, in vitro experiments show that the drugs based on co-scientists suggested epigenetic targets reduce the fibrogenesis in human hepatic organoids. So what they are saying here is that the AI co-scientists actually proposed a few antigens, let's simplify that if targeted by appropriate medications could reduce the amount of fibrosis within the liver. And they actually went to the wet lab, developed those medications, and then checked it out on liver cells in vitro, and saw that actually those medications reduce the amount of fibrosis within the liver cells, which is really cool, right? You just give 2 hours or maybe a few hours, at most 2 days, to an AI system that is just working with a couple of agents and entire internet search to do, and then it comes back to you and gives you some proposals, hypothesis that is not just something that you and I can think of, even if we were experts in that field in a second. This is very, 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 very well taught. And now, if you actually go and test those, they are very likely to be valid. And again, I unfortunately don't remember what a specific problem this story happened about, but one of the main scientists working in the field actually claimed that, I mean, they were so amazed that they just wrote to Google and asked them, hey, did you by any chance have access to years of information and data that I had saved on my personal hard drives? Because the results that you came into overnight was something that I figured after years of research, and I have not yet published those. They are just on my laptop, and I'm pretty much sure that nobody has access to that. But this system actually came up with a conclusion. So very, very fascinating work.
I mean, yeah, this is mind-blowing, and it reminded me of a recent. I mean, I think it was published probably in the previous year, but it was the discovery of a new family of antibiotics after, I think, 40 years, I think. We haven't had lots of discoveries in the antibiotics before this new discovery by AI. That exactly, it was like AI was used to propose new chemicals that are easy to build in the lab, and they are able to kill bacteria or suppress their growth. And it was, I mean, this task was something that would take probably millions of dollars by these pharmacy companies to research on. And one model with a large pool of proposed chemicals was able to reduce their pool of viable structures to build in the lab into, I think, 20 or something. So the researchers only needed to experiment with those few structures, and then they found one of them that was easy to build, was stable in the human body, and it wasn't that harmful to the human cells, and it was able to kill those resistant bacteria. And I think these are things that we are already seeing the effect of AI into discovering new knowledge. And I think this line of research where AI is used to amplify the literature, the scientific literature, is the kind of the highest level of AI usage that will lead to the explosion of knowledge, as they say, and to the singularity that that basically you don't know what will happen after AI is going to be able to generate new knowledge that was not before known. Because in the other cases, okay, AI is probably diagnosing something. I mean, the case of medicine, that even you put lots of human effort into. People could also come up with the same results, but coming up with the new knowledge that is going to be discovered and then automating this process and scaling it is something that you don't know where it's going to end. And it is one of the most interesting results of these advances in the LLMs and AI picture.
I agree. I agree. I mean, lots of mind-blowing stuff happening, and I think that as we go forward, more of these things will come into real practice. I would say that research is an area that we have less obstacles for seeing AI entering into. So compared to clinical side, at least, so you have less regulations to deal with. So if an AI agent works like this, or a little bit simpler than these, all those deep research agents that nowadays are very common since 1 month ago. So I believe that the research labs are gonna become very, very much more productive. And this is just a transient phase until we see some agents or some AI systems that are fully automated. So they even don't need any human in the loop to generate new science. And then that would be
Yeah,
a more interesting phase of research that we might see in the future years. But at least for
yeah,
now,
definitely.
yeah, a lot of AI co-pilots to help with research. And maybe Moein, just very quickly, let's talk about, so far we have talked about how AI has actually helped biology and medicine, and now let's talk a little bit about how biology can help AI. And this was something that I saw 2 days ago. I don't think that the entire idea is very new. I saw some papers from 2022 to 2024, but something that caught my eyes recently was the release of product that was named CL1. Let me Google it again because I think this paper that I came up with, yeah, from Cortical Labs. And so this is a company that produces devices like this, which is very interesting because it's basically just using real biologic neurons for computing. And this basically is a computer case, but within that, instead of having motherboards or chips or things like that. I mean, we do have some chips, obviously, but the core is going to be just a very well controlled culture of human or other animal brain neurons. So, and those neurons are going to take care of all the computations. Now, obviously, this is a very, very primitive idea, but if you just scroll down, I believe I saw it here, but if not, I can go back to the previous paper and show that to you. Maybe they also have it here.
Yeah, they're going to disrupt the NVIDIA's kind of like
I
structure.
I do think that if one phenomena can put an end to this NVIDIA's dominance in the world of processors, are startups like this that try to disrupt the entire paradigm of processors as a whole. And
Yeah,
I bet NVIDIA is also probably having an eye on this, and they might even come and buy some of these startups before they become too dangerous for them. But at least the current idea of processors might change, not in a very far future. And this is the figure that I just wanted to share with you. So what you see here is actually a very nice representation, a schematic representation of of the processor. And you see that this is a very nice controlled closed loop system. You have a chip here, and you see some real biological neurons growing on that. And then you have a sensory region and an output region. And these are basically just chips, perceptory chips, computer-like chips that are there. And then what they achieved to do was that by just providing this system with some examples of that reminded me of reinforcement learning, but I'm not quite sure if it is reinforcement learning or something else. But basically, by just showing this system some imaging or some intuitions of a Pong game, they came up with a system that could play that game. And this is very interesting because now the brain behind the system is not any artificial neurons on our NVIDIA chips, but it's basically just real biological neurons that are like your brain, and my brain, and they're just doing this. This basically means that now we can come up with very nice interactions between biological processors and actual, traditional electronic processors. And this is interesting. This could revolutionize everything. And I believe, if nothing else, it can at least, help a lot with the cost of those electronic processors. Because not to say that these biological ones are cheap to develop and grow, but I believe in the long term, these are going to be much more accessible and much easier to regenerate and grow compared to the ones that are electronic. So very mind-blowing piece of research. And again, that lab that we talked about, Cortical Labs, it seems that that company is doing a lot of things in this field. There are multiple research papers already released by them. If you're interested, you can go and take a look at that. And then this CL1 is actually now for sale. I'm not sure how much they're going to sell it for. Yeah, they have not put any actual price here, but maybe if you are wealthy enough, go ahead and buy one of these and see if you can play a game on it. And if you did, let us know as well.
yeah. And one thing that's really blew my mind here, and I'm still thinking about is how they were able to kind of like convey the information from the game, probably some pixels or maybe some inputs, some digital inputs to these cells. What was that interface? I mean, we are seeing this sort of silicon interface with the natural kind of neurons with what Neuralink, for example, is doing. But I've always been curious about how those signals from the digital world is going or directed into these biologic neurons and how they know to direct these signals in an appropriate way and how they train those cells. I mean, yeah, on a technological level, I think this is a great advancement and lots of potential is there to do more complicated things in there.
Definitely. I mean, to be honest with you, I did try to read the last paper, this one, and try to understand it, but I failed. It's very complicated and it needs some level of biological understanding and computer science understanding.
Yeah.
But they have released so many papers, so I believe that, if we can just go through them, maybe we can learn the tricks behind this, and probably some people are interested in the field. But very mind-blowing research. And I guess this is going to be another trend like quantum computing that is coming up. Now we might also see this biological computing to be another trend following that. Not maybe very soon, but these systems are evolving. And now that we just see the first version that could be purchased, who knows? Maybe in 1 year, 2 year, 3 years, we see now more and more powerful versions of those as well.
Exactly. And I'm also thinking about how this similar technology could be used in the other way to augment our own brains with AI instead of augmenting digital world with biological neurons. And this is the area that's really excites me about the future to augment our consciousness with AI or with computers, basically, in a way that we have a way to convey our thoughts, our feelings into machines in a very efficient way, not just with words. I mean, imagine, I think we covered this in the previous episode as well, to just be able to uh, talk to computers in a much more efficient way than just words. Or look at it in this way, instead of just training models on the corpus of words that are generated by humans, training them on the neural activity of humans that then gets translated into words by our brain. But if you train it on the raw signals of the neurons before they're translated into words by our brain, I mean, that would be a much more detailed data set to train models on. And I think lots of more intricate relationships will be found in that sort of data set. I think that is a really exciting line of research that will be soon, I think, available probably in the next few years.
That's the first step towards a cyberpunk kind of world. I mean, we are just moving towards
Yeah.
cyberpunk, and I'm very happy because I do like Cyberpunk 2077 game. So I really hope
Mhm.
that by the time that I'm gonna leave, I see something like that happening in this world. Anyways,
Yeah.
these are very futuristic kind of works, and then I don't have anything else apart from some tools and resources to share. So I guess this is also the kind of case with you as well. So feel free to share your screen and let's go ahead and maybe do a last round of uh,
Yeah, sure. And okay, let me bring up the product hunt list here. Okay, at the end of each year, Product Hunt, which is a website that the new tools in technology, not just AI, is uh, introduced by its developers and are voted and ranked by the users and the community. At the end of each year, Product Hunt kind of like gathers a list of the winners based on the people's votes, and it calls the Golden Kitty Awards. And these are for the 2024. So we know lots of new and mostly AI-powered tools were introduced in 2024, at least A lot of focus was on AI. There are other tools that are not AI focused or not AI first in this list, but as you can see, the winner is Cursor. So this is the winner of all the categories, and it is Cursor, the AI code editor. And you can probably guess what impact it had on the developer communities that um, basically most of the people voting for these products are developers. So if developers pick this, they had probably a really good experience using this tool. And it's going to be probably the future of maybe development, at least on the indie or independent developers. Maybe it takes some time for companies to take on this Cursor AI tool as a companion to their developer teams, but for independent developers, this will be a great help. And yeah, I think we covered this in the previous section as well. And the runner-ups, well, Supabase, which is a really cool tool that I just found out from this list, but it has long been around. I just hadn't heard about it before.
What is
And the Open AI Award.
what is post?
I'm going to cover this in here. Supabase is basically a service, is backend as a service.
Mm,
So it provides tools for making very efficient and scalable backends, like the services that you need for database, services need for authentication of the users when they want to register to your website, or some of these serverless features as a service, basically. So you don't need to serve your own database on your own machine. You just use their API and yeah, use their database as a service. And let me share the, I think I'm sharing one tab here and I need to, maybe let me share my desktop so I don't have to um, re-share my screen every time I open a tab. I think you can see my whole screen here now with all the tabs. Yeah, this is the Supabase website. It is basically as in an open source Firebase alternative. Firebase is a service by Google that has been long around. It's not open source, it's closed source, but it was maybe one of the most successful backend as a service tools that was provided to the developer community, so that people didn't have to just develop everything from scratch, have their own database. They could use a database served on Google servers, but connected to their other parts, other components by some API. And it is the open source version or alternative to Firebase. And the cool thing is that the free tier version of Supabase provides lots of cool and lots of interesting features that are sufficient for running maybe a small to medium sized website. And then for the more advanced and those that need a really high scale scenarios, you can go to the paid plans. But the free plan, as I investigated, provides lots of features for free. That is cool. And I'm thinking to maybe whenever I wanted to build that personal blog, maybe I use some of these features from here and don't develop it on myself. But most of the time, these features and this service basically is more suitable for the big companies that they want to be scalable and they don't want to risk the authentication part to be, I don't know, easy to scam or something. And they also provide vector embeddings, which is cool. So this was the second kind of the runner-up for the title of the winner here, and the first the winner in the developers tool after the cursor. But cursor generally was the winner of the whole category based on probably the votes. The other cool tool was Bolt. I think I introduced it to you
yeah,
someday. I'm not sure, but it wasn't recorded in the
yeah,
episodes.
I remember.
It's basically a tool. Yeah, it's basically a simple here at least. interface that lets you type in the app you want to develop and it starts developing it. Yeah, as unbelievable as that sounds. And I tried it with some ideas, and it is good on the HTML, CSS part. It probably takes a lot of prompt engineering and trial and error to make a whole functioning website with it, and it's not probably very efficient on I don't know, handling the database or something like that. But it is definitely a good a starting point if you have some idea to work on and want to just play with the idea and see how you can develop it as fast as possible. As I said, the vibe coding thing, like, and see if that is feasible to do. And I saw some of the tutorials on YouTube that were using this tool as the main kind of like tool to develop the front end of their website, and it's really intrigued me to try it for the cases that because I'm not good at front end. I know a little bit back end to develop with Python, but for developing the front end, I think this one is going to be a really good tool, at least to try out. And it is much more complicated than just the front end. It can basically, or in theory at least, develop and deploy full stack web and mobile apps. But in the cases that I was playing with, the part that really intrigued me was the front end applications. So I'm not sure if you had any experience, any
No,
successful experience with this one.
I did not, and to be honest with you, the reason that I did not, it was on purpose because I am just learning, as you know, these front end frameworks, and I really didn't want to hinder my progress by just relying on these automated tools. I know that they do great, yet I still believe that if you really want to become a web developer for developing something that really is, a comprehensive solution to the problem, you just need to know the basics. Yeah, I mean, you can certainly rely on Cursor or Volt or everything to come up with a weblog for you, but the moment that you just want to change one aspect of those, if these models themselves cannot do that for you, then you are in a big trouble because now you're looking at a code base with maybe thousands of scripts and thousands of lines, and then you don't know how it is actually put together. So I really like this. I think that these automated tools are great. I mean, Cursor itself is great. But when I am in the learning mode, I usually use VS Code itself, not Cursor, because I just want to force myself to code and learn how things are in the first place and then go and use that. And Moin, actually, you reminded me of something very nice that I read past couple of weeks on Twitter. I don't remember from whom, unfortunately, but it was like this, that every time that you use one of these automated tools, I believe I sent it to you, I'm not sure, that you are kind of financing a very nice product that you desire, which is going to be super useful in the beginning, but in the long run, you need to pay the money for it back. So,
It's a technical debt kind of thing, yeah, that
kind of
you take, yeah.
So you just borrow a huge amount of money. You just basically borrow a full stack project, a very good looking website in the beginning. But the moment that you want to change something in it, now you need to go back and you need to debug a lot of codes that even if you know that language, the entire project is written with, you still need to figure out the logic of the code. So I would say that these things are great, and hopefully there will be a time, and I do think that there will be a time that they can be 100% automated, so they can create everything for you and they themselves can take care of just debugging whatever problems there are there, addressing every single request that the user has, adding whatever features. They are not necessarily too verbose, they are not necessarily too concise, and we will see that day, but we are not yet there. And this means that if you just rely on these tools to build something for you and you yourself don't want to touch anything, you don't know anything about that language that is being used, if you are dealing with something that is not simple enough, then you are going to be in a big trouble later on, unless if you don't want to. So that's my take on these things. But these are very cool, and I believe these are the preliminary steps towards those 100% automated solutions.
Yeah, definitely. And most of the tutorials and applications I've seen online using these tools are most of the time for building demos of some ideas that you have in mind. And I think it makes sense to when you are not sure whether something is feasible and you just want to play with it and see if it can be made into an app, an actual app. It makes sense to maybe start with these tools, and then when you had some evidence that okay, this is doable and it could look nice if done right, then you can start from scratch and develop it with a long-term view so that it would be easy to maintain in the future and in the long run. And yeah, I agree with that.
Oh, okay, nice. Very nice.
And yeah, for the design tools, Figma seemingly has a Figma AI extension that I didn't play with these myself. I'm far from the design area, but probably maybe you want to try them out. This one had a really good idea. I'm not going to share the website. I'm not sure if the internet bandwidth will allow, but this is actually a gathering or a gallery kind of like of all the design inspirations and includes the user journeys of applications that you can get some inspirations from. So you have some idea in mind, but you don't know how to design the app, how the interaction of the user with the application should be. And this is just a gathering of all the good products out there, and you can just get some examples from. And I think it was a really good idea to just build it.
Nice. So do you want me to share the screen for that app?
Yeah, yeah, go on.
So let me, so if you have other things to share, maybe, oh, you already stopped sharing. I just want to say maybe that,
Yeah, it's fine. Yeah.
let's do that. Okay. So let's see. So this is the website that you're talking about, right?
Yes. Yeah.
Oh, and again, so this is just showing a UI for different applications. What does it exactly do? I didn't get it.
Yeah, it shows the AI, the UI. We were too much using the AI word.
Ah, exactly.
And it shows the, as far as I understood from the examples that I was seeing there, the user journey in those applications. So, what are the first pages that that the user sees when they log in, and what are the different features that those previous applications provided? So, when you have access to all those high quality applications that are already existing, you can probably come up with your own design much more simpler by having access to such a kind of like database of user interactions.
I see. So I tried to do a quick sign up on their website, and I am seeing now a lot of applications here. Nice. So it's basically just a user journey, a compilation of user journeys across different apps. I mean, this is a great idea. See,
Yeah, this was something that needed to be done.
yeah,
I
I
mean,
mean,
gathering these user journeys
exactly.
and it really helps designers to just come up with the new design much more, or take the best elements from each of the designs and put into a new application. Yeah, as you can see, every page that the user sees during the sign up, for example, in the cloud application is gathered here. So you can get a whole view on how user interacts with these applications.
All right, yeah, and they're charging $10 per month for the full usage, but even this one is actually already too enough. I mean, for lots of the things that you want to do. This is Arc Search. And by the way, I mean, I should once talk about Arc as well. I just basically set
Mm.
Chrome and kept using. This is Arc. This is the browser.
Yeah, I was going to mention that, but I was seeing this tab that you were opening, and I was, this seems familiar to me. Which browser are you using? And yeah,
Arc, and to be honest with you, my Chrome was just getting too slow. I'm not sure why, but this has some very cool features. The one that I really like and I use is this two tabs in the same tab that you can use, and this is super nice. uh, during browsing. This helps a lot, and it is a very cool project. You basically have all the extensions from Chrome available here as well. So nice one. I
Yeah,
would
and Arc Search is the third in the category of mobile apps in the Product Hunt award. So it itself is listed in this award.
cool, cool. Yeah, and they have lots of screenshots from that. Okay, nice product. Thanks for sharing this. This is also very interesting.
Yeah, and I think the last application I wanted to share from this list is this one, which is a really helpful aid for myself at least, is Postgres.new. And let's see how this works. This is basically an AI assisted version of Postgres, so you can just describe the application that you want to build, and it tells you what should be the structure of the databases or the tables in the database, and it gives you the code for the migration. So just you can copy and paste into your development environment. For example, you can say, I want to make a to-do list application, and it designs the tables, and you can just chat with it to change the architecture of those tables. And yeah, it says, okay, for the tasks, you need a table with these um, characteristics, and it should be related to these categories table. It tries to give you the most efficient way that you can design the database, and the migrations are available here, so you can just copy and paste these codes
Oh, this is
into your code. Yeah. And yeah, you can chat with it here to say, okay, I want, for example, the users table to also have a profile picture section. So it adds that, and I can just go on and ask it. Add um, add to the users table the um, profile pictures kind of like feature as well. And it updates probably the table, yeah, the profile picture URL, and then the migrations is also updated here at column profile picture.
one question.
Yeah,
Can you directly edit the diagram itself?
let me see. Um, I think I clicked something wrong here.
Probably just
Yeah, just do it once more.
maybe edit, maybe renaming some of the keys or adding a new row, something like that. Because if that is also included, then this is a great solution. I mean, even right now it is a great solution that you can just chat with it, but sometimes it's much easier rather than asking it to do something for you, just go there and add that row there.
Yeah, I'm not sure what happened here, but okay. Yeah, rename column, make nullable, make unique. So yeah, you can change some of the characteristics here as well.
Create index. Maybe click on that create index and see what happens. Nothing. Okay. I'm just,
Let me choose the best index for the ID in the so it basically wrote a prompt there. For example, you can make the password hash the index maybe. Let's see how that works out. Yeah, it tells you that there are security concerns. So the fact that it tries to come up with the efficient and an efficient architecture for a database is very cool, because this is the area that I'm not very familiar with, how to design efficient and these related tables. And it's cool that these AI assisted tools are proliferating in all areas of coding. So it makes it much more simpler. I mean, you could put a lot of time on learning how to write a good SQL code for making tables, but using these tools, you can have an easy start. I'm not sure if this is the best start that you can have based on what we talked about in the if we want to consider the long-term effects, but it really helps just to start
yeah.
coding and working on the projects that you had long in your mind.
I agree, and this is a very cool. I don't know. So, what was the name again, Moein? This one, Postgres dot
Database.build.
database dot
Yeah,
build.
yeah,
Nice.
the website is there.
I guess
Yeah.
the combination of these tool and the first one that you mentioned, which was like a
Yeah.
base, something like that.
The Supabase, and this is basically a tool, I think, by the Supabase team, and you can
Ah,
connect it to, so that when you created your database, you can deploy it directly. So yeah.
so help me understand now, for example, if you want to build a RAG application that you,
Hmm.
I mean, and it's going to be, I mean, if I wanted to do that conventionally, I would probably just put together a server and set up a Postgres database on that, and then maybe come up with a fast API, kind of very simple backend for that, and then the front end could be a Next.js or whatever application,
Yeah,
and I would just use that. I mean, I will keep the server on, and whenever someone logs into my API, they're going to interact using the front end with that backend, and they receive. Now, I believe this could be easily handled in a serverless manner using these tools that,
exactly.
right? I mean, it's
Yeah. Yeah,
super.
you can outsource the database part of your project and lots of other features of your project to Supabase, and just maybe I think there is the possibility that you can also outsource the front deployment or the server that is serving the front also to Supabase. But just imagine the case that you yourself want to serve the front end on some server. You can connect that front end with these APIs to those databases that is being served on Supabase servers, and yeah, you just outsource a big part of your project there.
So we have a couple of very nice solutions for front end already. One of them is Vercel, as far as I
Yes, yes.
and let's see if they can be connected to each other, Vercel and Supabase. Supabase for Vercel. Yeah, by integrating Supabase with Vercel, developers can leverage a Supabase Postgres database out and storage, edge functions in real time while benefiting from Vercel's free deployment capabilities. So it seems that, yeah, you can do both, which basically means that now you have a free solution for your front and now you have a serverless free option for your back. And then it's gonna be a very nice one.
Yeah, and one thing that is definitely happening in the whole picture of these tools is that developing new applications is just getting easier and easier. The bar is getting lower and lower.
Yeah, yeah, yeah. And again, this means that everybody can now come up with their own ideas and maybe, as they mentioned, really in across a weekend, just put together something, a project, a product, and launch it. And people are saying that, very soon we are going to see 1%, 2% worth of, the startups with 1 billion, 2
Exactly.
worth of money. So this is something that is going to happen if, thanks to these tools that we have now. I mean, you do not need to have a full engineering team to build a website for you. You can just leverage these tools and do everything yourself. Very nice tools. Very, very nice tools. All right.
And so my list finishes here
Okay.
somehow. And yeah,
So I have
feel
a
free
couple of
to.
things to share, but I'm gonna be very quick because I think we already are been speaking for 2 hours
Yeah,
and a half. So I'm gonna make it very quick now. Let's see what to talk about. I'm going to maybe one thing to talk about very quickly is chain of draft. I guess this is a nice paper to talk about. Let's go through it together. All right. So, we are all familiar with chain of thought. I believe there is no one here that is hearing us that does not know what chain of thought is. So, chain of draft is actually an advancement of thinking acceleration tips for non-reasoning LLMs. Meaning, if your LLM is already reasoning, we do not usually use chain of thought with them, right? This is mostly for GPT-4o kind of models that are not reasoner at baseline, or maybe some people can later on use this trick to train, reasoner models based on that. But for now, say for example, if you are just dealing with GPT-4o mini, or you're typically dealing with a model that is not reasoner, Cloud 3.5 Sonnet, for example, you can just use this trick, and it is very, very easy and cute to implement to get much better results from your models compared to chain of thoughts. So let's first take a look at this diagram here. This basically shows the performance of these three different modes of question and answering. The standard mode, which basically means that without any chain of thought or chain of draft. The chain of thought is the yellow one, and then we have the chain of draft, which is the orange one. And as you can see, when you look at the accuracy in most of these benchmarks, the chain of draft is actually on par, if not better than the chain of thought. And if you look at the token count, which translates to cost, chain of draft is much, much more efficient. And the way that it works is super simple. So in chain of thought, you basically ask your model to start thinking and reasoning before it answers you, right? Say, for example, you have this question here and the model goes through the question. Let's think through this step by step. In chain of draft, your model is still thinking about that, but it is tasked and it is forced to think as short and concise as possible. Say, for example, this question here is basically asking the model to solve a very simple equation. And here, instead of just having the model in chain of thought to basically, as you can see, it has just generated lots of sentences. It just puts together a very short, concise annotation of the equation and just solves that for you. This is the entire story. And they're saying that this is much closer to how humans actually reason about the stuff. They say that, however, humans typically employ a more efficient strategy. They draft concise intermediate thoughts that capture only essential information. So basically, humans are not using chain of thought. They are mostly using something that is similar to chain of draft. And again, the prompt for doing this is very simple. So this is the standard prompt. Let's find out the, here you go. This is answer the question directly, do not return any preamble, explanation, or reasoning. Chain of thought, think step by step to answer the following question, return the answer at the end of the response after separator. And now chain of draft, think step by step, but only keep a minimum draft for each thinking step with 5 words at most. Return the answer at the end of the response after separator. And the key here is this 5 words at most. And apparently this cute trick works so beautifully that this technique outruns chain of thought across almost all of the stuff. And it kind of makes sense when you look at it retrospectively. I mean, these tricks do not come to mind prospectively that easy. So kudos to these researchers. But when you look at it from a retrospective angle, I mean, this makes sense because you are just shortening the context window of the amount that you put in the context window of those models, and it still works very nicely. So this is one cute paper. Yeah, go ahead.
And it's really interesting that, I mean, I was expecting some sophisticated RL that has been utilized to make the model use the least amount of tokens, but with just that prompt, everything has changed. It's so cool that these new types of research is being published. And yeah, definitely it's not easy when you are researching this question. It only seems simple or cute when you look backward. Yeah.
Exactly. And to be honest with you, I think that this same way of thinking is also being explored by other researchers. So for example, this paper, I'm not going to deep dive into it, but these people are basically using the same trick, but not during inference, during training. So it is, the paper is named Light Thinker. So they are basically offering a schema for training a model, but instead of having that being trained on the entire reasoning schema, just being trained on very concise schema during the training. So again, this is a line of work that we probably are going to see more and more. And I guess that the next line of reasoner models are going to be using this trick more and more often, because we know that reasoning and reasoning during inference time is also not that cheap. So you need to pay money for every single token that the model is generating.
Yeah.
All right, so that is it. Let me see if anything is left here. A couple of things to mention to you. One of the nice ones is actually, I'm going to introduce 2 resources. One is a kind of book that is released on Archive, a comprehensive guide to explainable AI. And if you open it, this book is very long. I mean, this is an entire book, right? A very, very nice one, released on December 2024. So it's still very up to date. And if you just go, and it's coming out of a lot of different centers and people with multiple different affiliations. So kudos to all of them. And they put together a very nice piece of reading on introduction of explainable AI, foundations of that, What does it mean to have explainable models in deep learning? And then they talk about interpretability of large language models and transformer architectures, which is state of the art at the moment. So if some people are interested in doing research on explainable AI, I believe this book is 230 pages, obviously not an easy read, but this is the most comprehensive introduction that you can find to any explainable AI territory. So definitely give it a try if you're interested.
Mm, very interesting. Yeah.
Yeah, this is one, and then the very quickly the next one, which is probably less relevant to people like you and I, Moein, who are not training our own models, but still it might satisfy our curiosity. This is the ultra-scale playbook regarding training LLMs on GPU clusters. So basically, a group of researchers revealed all the tricks for training LLMs on GPU clusters. This basically means that now, and this is a very, very, very long blog post. This is also kind of a book itself,
Mm.
but very nice with great figures. And I believe they start from the scratch. They explain all the concepts and then how you can train a modern LLM on a GPU cluster of 500 GPUs, for example, because neither of us are used to that number of GPUs. I mean, the most number of GPUs I've ever trained on my life has been 8 using DTP. And 500 GPUs definitely will open the door to many different errors and issues and challenges that I even cannot imagine at the moment. So if people want
Yeah,
to
this is
start
a
with things, go ahead.
Yeah, this is a really precious resource and the type of resource that and content that is not shared regularly, and it is probably only locked into the teams of Google and OpenAI, and it's really valuable that they are sharing their experiences here. And I can see Thomas Wolfe in the authors, who is, I think, the CTO of Hugging Face, or CTO of Hugging Face, I think.
Exactly.
Yeah, very definitely. It's going to be helpful for many people.
Now,
Not me, but many
yeah,
people.
we don't have the resources to train on this amount of GPUs, but again, many researchers might benefit from it, and kudos to Hugging Face for open sourcing such a precious uh,
Yeah.
document. Then let's see what else do I have here to share with you guys. This paper was kind of interesting. I'm just quickly going through that. This is a blog post for the paper. The paper itself is also available. It's named Minions, Embracing a Small Language Model, Shifting Compute on Device, and Cutting Cloud Costs in the Process. The idea again is very simple yet very effective. They are saying that, basically we cannot use our own laptops and computers for very complicated tasks because we cannot run state of the art large language models on them. What if a state of the art large language model acts like guru and tells a lot of smaller language models, each of which could be a minion, to do what exactly, and then the complicated piece of computation is still done by the guru on the cloud. So the idea is very simple. They said that whenever the user asks for something, a cloud-based model. Let's figure out the paper. Here we go. A cloud-based model is going to come up with a plan, and it's going to give very, very small tasks to those on-site local models. Like, for example, if we are just thinking about a very complicated framework, this is a small piece of that go and read this document, tell me this answer, which, maybe a Moein or, a Mistral or a Llama 3.2 8 billion parameter can easily do, can handle that. Those small models go and do everything, and they come back to their boss, say that here's the results, and then the boss on the cloud takes care of concluding everything and answering the user. The main magic happens because those compute heavy part that, for example, a model should go through a very large corpus of document to find a small answer could be done by a local model. And the amount of money that you're spending on the cloud models is very, very limited to those few tokens that are exchanged between your computer and the cloud. Again, very nice, interesting
Yeah.
piece of work. And I
Yeah,
want,
thank
yeah,
you.
you want to share something? Oui?
Oh no. I mean, I said thanks for sharing. It's really a useful concept to have in mind on how this whole thing could be more efficient.
Yeah, very, very cute ideas. I mean, I did this past month, I found a couple of cute works, and let me finish by the one that I really enjoyed. which is this Mistral OCR. I'm not sure
Yeah, yeah,
if you heard.
yeah.
This is great, man. I mean, I used that past couple of weeks, and I it was such a flawless experience. I mean, this is a paid API, but you are going to end up paying $1 for 1,000 pages of PDF to be translated to Markdown,
It's amazing. Yeah.
which is nothing. And it works so nicely that I believe, I mean, if you just try to come up with your own hard-coded script to do these things, it's going to be much, much more challenging. It's a very nice API. You just go to Mistral, you basically click on this try the API. I have already activated my own API. It's very simple. You get some API keys. You can manage your usage and limits. And again, I believe somewhere they talk about the way that they do that. If it's not here, probably in there. I believe I read it somewhere. But this is the amount of. So look at this. This is the PDF, and then this is the Markdown generated, and they can
Uh,
come up with a very accurate with imaging, a very accurate representation of the PDF in Markdown, taking care of the tables and everything. This is the table. If you see,
yeah.
translated. The images are gonna be
Okay.
extracted, are gonna be saved locally. You can easily save this markdown to disk, and then we know that markdowns are much easier to be processed by language models, and
Yeah.
the images are saved, and the images are going to be saved with appropriate hyperlinks within the markdown files. So you can just easily use OpenAI API, for example, or Gemini API to pass the imaging with their names and then the markdown, and those models behind the scene can understand that, okay, this is the image that has come in this specific part of the page. Great. Very handy tool.
Um,
So just wanted to share that with you. I've been using
Yeah,
that.
thank you. It's really interesting, and it's cool that each of these companies are coming up with their own unique features
Yeah.
to open source, not open source, just to uh, give people access to these different features. I think not OpenAI or Anthropic are working on this OCR API, but this could be something that I mean, you don't have to now rely on your own code base. If you want to build a RAG system, you can just pipe the whole PDF to this API and it will probably be fast, and then get back the
Yeah,
markdown and use it in the context of the LLM. It's
exactly.
really interesting. Everything is going to be cloud based in
Cloud-based, and yeah, you basically are need to you need to come up with a way to manage your APIs. To be honest, one of my biggest frustrations at the moment, Moein, is that I have too many API keys, and I should keep track of those, know how much I'm spending on any of these, and things could get easily out of hand. But this is the future. This is the future of development world, at least. So we need to get used to that.
yeah, an interesting future, of course.
Very interesting future. All right, so I'm also over now. This was
It was great. I mean, I learned a lot, lots of new content and interesting things to just dive deeper into after this meeting. And yeah, like always, I really enjoyed it.
Thank you very much. Likewise for me as well. Thanks for introducing the last piece that was super awesome, those nice products on Product Hunt. I'm going to study two of those at least tonight and understand what they're doing. Very handy. All right. Thank you very much, Wayne, and thank you everyone who were watching us. This was a very long one, but this was never supposed.
We needed to cover a lot of things, so yeah.
I mean, this is not supposed. I mean, these videos are not supposed to be short, and I believe, and Moin and I never stopped shorter. We never had shorter than 2 hours conversations, even
I don't think so.
recording these meetings. So yeah, we are not going to limit ourselves. So hopefully you enjoyed that as well, and see you in the
Yeah,
next.
next episode.
All right. Goodbye, guys.
Bye.